Okay, hello and welcome to a lesson about Fermi problems. What a Fermi problems is and how you can use it. So I saw a question that was, would the sea level lower if we took all the boats out of the water on Earth? That's the sea level of the oceans. Now this is a Fermi problem. And Fermi comes from the Italian physicist Enrico Fermi, who said that a real physicist should be able to calculate everything close to a magnitude of 10. That is, don't be wrong with more than 10. That's 10 times as much or 10 times as little as your calculation showed you. So I will try to calculate this. Would sea level lower if we took all the boats out of the water of the oceans? And you know that sea level is rising if you put something in it. If you have a pool, a swimming pool or something, and if you put something in the water, the sea level rises. That's true. So we have to do some assumptions now. That's what physicists normally are quite good at, even if it's hard. And we are quite nice when we have a Fermi problem, because the error could be very wrong, because there are so many uncertainties, so many things that we don't know. Well, what we do know is that we are approximately on Earth 7.5 billion peoples like this. And I'm starting with this because I need to find out how many boats, how many ships do we have. Now, it's a very problematic question because they have different size and so on. So in my country, in Sweden, I would assume that like we have one boat on like every maybe 20 persons or so on. But they are very small. Most of the boats are very small. But you know, there are also larger ships all around the globe to serve people with supplies like cars or oil. There's lots of oil ships and also cruisers with people in them. So I need to estimate how many bigger boats do we have on planet Earth. Now, one estimation could be that we need one bigger boat for every 10,000 of person on Earth. For every 10,000 persons, we need a bigger boat that is going with cars, with iPads, with telephones, with oil, and so on. So if I take the number of people on Earth and divide it with 10,000, then I get roughly how many bigger boats do we have on Earth? It could be very wrong, but probably not with more than 10. Now, you know that this will be 750,000. You can take away zeros because you know maths here. So this is how many bigger boats we have on Earth. A very approximate, well, it's an approximation. Now, I need to find the mass of all these ships or boats. So there are 750,000. And there are ships that has a mass of much more than 100,000 tons. Very big ships. But there are smaller ships as well. And there are boats, very small boats for one person. Well, let's say that in average, and that this may also be very out of range now, but let's say the average mass of a boat is 50,000 tons. That's like Titanic in average. So today Titanic would not be that big ship. It's quite average or so. So 700,000 boats, ships in average, with a mass of 50,000 tons. There are probably many, many more boats, but most of them has a small mass. So maybe this could be something in average. Well, that is 3.75 times 10 to the power of 10 tons. If you use scientific notation now, because the number is so great. Okay, then you know Archimedes, that Greek guy, Archimedes, that brought up in Sicily, in Syracuse. That would be Italy today. But back at those days, 2,400 years ago, he was a Greek. And he said that for every ton of water, you need to press away the volume of 1 cubic meter, because 1 cubic meter has the weight of has the same weight as the boat has for the tons. So okay, that means that these masses of boats needs to press away the volume of 3.75 times 10 to the power of 10 cubic meter. Because 1 cubic meter has more or less the mass 1 ton. You know that. It's not that perfect exact, but more or less. 1 ton and 1 cubic meter of is the mass of 1 cubic meter of water. Okay, that's the mass of, that's the volume of all the boats that we have. The volume of all the boats that's under sea level. That is what Archimedes has said. Now, I need to find out the area of all the water on Earth. What's the area? And the area of a globe, you know, the Earth is a globe, and you calculate it with 4 pi r squared. However, it's water on only 70% of the Earth, so we have to multiply it by 0.7. And then we get it in square meter if the radius is in square meter. So let's calculate the area. So it's 4 pi, and the radius of the Earth is like in average, because you know it's suppressed on the poles and a little bit bigger on at the equator. So this is the radius in meters. You square it and you multiply by 0.7 to get it in square meters. Now, that's the area. You know that volume of an object depends on the area and the height of it. So now is the question, if I have this volume, because this is the volume of all the boats beneath the sea level. So if you have that volume and you will put it on an area, that's the area of all the oceans on Earth, what would the height be of that volume? If we could answer that question, then we know the height that would go away if we took away all the boats. And from the course in maths, you know that you have to take the volume and divide it with the area. So in this case, the volume was 3.75 times 10 to the power of 10, and we divided it with the area of the where we have the water on the Earth, and that would be 4 pi 6370000 to the power of 2 times 0.7. And you use the calculator, and I have already done it. And if you do it, you get a value that is like 0.0001. And the unit has to be in meter, because the volume was in cubic meter and the area was in squared meter. So this will be in meter. Or if you have a unit that's more comprehensible now. You can move the comma sign 3 steps and we get it to 0.1 millimeter. So you could say that the volume, if you took away all the ships, the boats on all the oceans of the Earth, it will go down with 0.1 millimeter. But there's lots of estimations now, so maybe it's just 1/10 of this. Then it's enough for a good physicist. So maybe it's just 0.01 millimeters or so on. But some not maybe that very far away from this. So it doesn't help when we have increasing sea levels because of climate changes. Can't help the world with that. Okay, thanks.